All right, so we're going to take a look at exercise number 1, and it's asking us again to use elimination to solve this system of linear equations. So our system reads 6x minus 7y equals negative 10, and 3x plus 7y equals negative 8. So I'm lucky here because I can actually eliminate my y variable because I have a negative 7y and a positive 7y. So I am simply going to set these two equations I'm going to add them together, which will allow me to eliminate that y variable and solve for x. So I've got negative 10 plus negative 8. So remember, since I have a negative 7y and a positive 7y, they are eliminated. So I now have 6x plus 3x equals negative 10 plus negative 8. So now I'm going to combine like terms. So I've got 6x plus 3x, which is 9x, equals negative 10 plus negative 8 is negative 18. So I'm going to divide both sides of this equation by 9 because right now 9 is being multiplied by x. So now I have x equals negative 2. So that's one of the two parts to my solution for this system of linear equations. So now I need to plug that x value in to one of the two equations and solve for y. So this was my first part. Here's my second part. I'm going to use the second equation because I like it better. Plus 7y equals negative 8. And now negative 2 times 3 is negative 6. So I've got negative 6 plus 7y equals negative 8. So I'm going to add to both sides plus 6. So now I have negative 2. So I've got 7y equals negative 2. And now I'm going to divide both sides of this equation by 7 to get y all by itself. So my y value is negative 2 sevenths. So that is the solution to this problem right here. Negative 2 and negative 2 sevenths. So my the solution would be found on along the x-axis at negative 2 and the y-axis at negative 2 sevenths. So this was one of the easier ones for us to solve. Let's take a look at one that won't be as easy. So I'm going to jump ahead now, and we're looking at number 2. So number 2 is x minus 4y equals 7, and 5x plus 9y equals 6. But we're really happy with this system of linear equations because we can simply multiply the first equation by negative 5 because we have an x all by itself. So we can manipulate the first equation so that we will be able to eliminate x. So we're going to multiply the first equation by negative 5 because remember we're trying to get it to be negative so we can eliminate that x variable. So I'm going to use my distributive property and I'm going to multiply negative 5 by everything inside the parentheses. So I've got negative 5x plus 20y equals negative 35. And since I can't see this, I'm going to erase that. And now I'm going to add these two equations together in order to solve for y. So I've got 5x plus 9y plus negative 5x plus 20y equals negative 35 plus 7. Nope, that's not right. Negative 35 plus 6. Sorry about that, guys. All right, so now since I can eliminate my x because I have a negative 5 plus positive 5, now I have 9y plus 20y equals negative 35 plus 6. So I'm going to combine like terms. So I've got 29y equals negative 35 plus 6 is negative 29. So I'm going to divide both sides of my equation by 29 to get rid of the 29 in front of the y. And so my y value is negative 1. Now I just need to plug into one of my two equations a y value of negative 1. So I'm going to choose the second equation. I don't know why. Multiply by, I'm solving for x. So I've got 5x plus 9 times negative 1 equals 6. So now I have 5x minus 9 equals 6. And to that, I'm going to add 9 to both sides. So I've got 5x equals 15. And now I'm going to divide both sides of my equation by 5 to get x all by itself. And so I just determined that x equals 3. So the solution to this system of linear equations is 3, -1. And I actually really like that because the graph would be really easy to see where the two lines are crossing. So we really like integers. We really like 3 and -1 as a solution to a system of linear equations. So that was another one that wasn't too terribly difficult. We're going to look now at one more where we have to do some manipulation to make it so that we can eliminate a variable. So I'm going to jump ahead. Remember, I am posting this video, so if I'm going a little bit too fast, it's just because I'm trying to make sure I have enough time at the end for questions. You can always go back and look at this video when you're done, when I post it, so that you can get all the notes. All right, so I have 2x now minus 3y equals -5, and 3x plus 5y equals 1. Now I have to do some manipulation. So I'm going to use my x variable as what I'm going to eliminate. So I'm going to multiply my first equation by -3 because I want to get rid of my x. So I need to make it negative. Minus 3y equals -5. So I'm using my distributive property, and I've got -6x plus 9y equals 15. Okay, so now I'm going to multiply the second equation by 2. So I've got now 2 multiplied by 3x plus 5y equals 1. And I'm again using that distributive property. So I've got 6x plus 10y equals 2. And now I'm going to add these two equations together. So I've got -6x plus 9y plus 6x plus 10y equals 15 plus 2. So I can go ahead and eliminate my x variable because it's a -6 plus a +6. So I'm left with 9y plus 10y equals 15 plus 2. And 9y plus 10y will give me 19y, and 15 plus 2 is 17. So I'm going to divide both sides of my equation by 19, and I'm left with y equals 17 over 19 with no hope of reducing that any further. So now I need to plug 17 over 19 into one of my two original equations to solve for x, to get my x value that is the solution to this linear system. So I'm going to plug it into the first one. So I've got 2x minus 3 times 17 over 19 equals -5. So I've got 2x minus, because a negative times a positive is a negative. So -3 times 17 is -51. So I've got -51 over 19 equals -5. And unfortunately, I have to do one of those. I don't really like to do it, but I'm adding 51 over 19 to both sides. And this time, just to save a tiny bit of time, I'm going to use my calculator. So I've got 2x equals -5 plus 51 over 19. And that gives me -44 over 19. And now I'm going to divide both sides of my equation, or really multiply by 1/2. So now I have -44 over 19 divided by 2 is -22 over 19. So my x value is -22 over 19, meaning the solution to this linear equation is -22 over 19 and 17 over 19. Now notice again how those denominators are the same. So remember, when you have a solution to your linear system and it is a fraction, they are fractions, they will have the same denominator. So please keep that in mind. All right, so that takes me all the way to the end of my lesson, but there was one more thing that I wanted to go through with you guys before I finish this. So I'm going to go back. This is really a review of the 3 different ways that we can solve linear systems. So today we looked at solving linear systems through elimination. So that was what we did today. But we have also looked at solving linear systems through substitution, and we've looked at solving linear systems by graphing. So, systems of linear equations can be solved by eliminating one of the variables from the system. One way to eliminate a variable is setting both equations equal to the same variable and then writing the equations equal to one another. So, for example, this first problem, this first example, both of the equations read y equals. So since y equals, we can set those two equations equal to each other and solve for x. And then we can plug the x value back into the equation and solve for y. So that is one way that we can solve the system of linear equations by elimination. Another way to eliminate a variable is by multiplying each term of an equation by the same constant to make an equivalent equation. Then use the equivalent equation to eliminate one of the variables and solve the system. And so we looked at this today as well. We would multiply it by a number, a constant, both equations by a constant, and then set those equations equal to each other, meaning we would add the equations up and solve for one of the variables and then plug the other variable back into the equation, into one of the equations and solve. And then we also have, those are the two ways that we were using elimination today. We can also find a solution graphically. So remember, we can graph the equations and find the solution that way. And then we can also use substitution. So we used substitution yesterday when we were looking at solving linear systems. So that takes me all the way to the end of my lesson.